All right, guys, we got 6.6. We're going to interpret the applications of the derivative, or the derivative and the definite integral. So, did you guys do this one by hand or with a calculator? Let's do it by hand. I like it. I like the way you think. All right, so first thing I'm going to do is find my critical points, right? So, that means I need to know, I guess I need to know when it equals 0. 2t squared plus 3, which means negative 3 halves equals t squared. It's always going the same direction, right?
Because anything squared plus a number is always positive.
So it's always going the same direction. So I'm going to integrate from 1 to 5. Technically, I'm still going to put the absolute value, even though it doesn't actually need it anymore, because I know it's always going the same direction.
And you have to know the exact value.
And shall we do it by hand?
You didn't answer my question.
I didn't hear your question.
You need to know the exact value of t.
Yes, but there isn't one. What? Exactly. So now we're going to go ahead and we're going to do this, which would be 2t cubed plus 3t evaluated from 5 to 1, which is going to be 5 cubed is 125 plus 3 times 5 is 15 minus 1 plus 3. So I get 140.
1 plus 3.
Why do you do that?
What did I do wrong?
Why are you plugging in?
2t squared is actually 2, no, it's actually t.
You're right. Thank you. You're right. You're absolutely right. I just saw the 2 and 2 and canceled it. Thank you. You're right. It should have been 2t cubed over 3. Thank you.
So then, in the parentheses,
Why?
instead of being 1, it would be 2/3. No.
Yeah. But we're going to have to change this one too.
Mister, why?
So,
It's going to be 83.33.
guys, I cannot do it if you're all talking at the same time. If I do, it's down there or in the drawer.
These are going to be 80.
And this one over here would be 2/3 plus 3. All right, now let's work that out. That does not divide by 3 nicely. That sucks. That's going to be 250 over 3 plus 45 over 3 minus, that would be like 9 over 3, so minus 11 over 3. It's going to give me 295 minus 11, 284 over 3. Let's put that in our calculator. What do we get?
94.66.
94.6 repeating. Okay, now I will take questions. And if you are talking, I need you to stop. Whoever that is. I can hear somebody over here. Yes.
How are you doing how do you get from 2t to 2t3 over 3?
So when we integrate this, we add 1 to the exponent, which makes it 3, and then we divide by that new exponent of 3. Originally, I had just seen the 2 and 2 and thought it canceled, but that was just me doing it quick in my head, so I made a mistake.
I'm sorry.
So you add 1 to the exponent, which makes it 3. Divide by the new exponent. That's it. That's how we integrate. Okay? You need to be quiet. All right. Let's do it. So, if we have the derivative of an amount, then that is the rate at which the amount is changing. Okay, so if we have water being drained from a swimming pool, and r of t represents the amount of water, well then that would mean that r prime of t is that derivative, and it would measure how fast the rate at which the water is changing. Okay? What would the units of r prime of t be? If we look up here, what did it say?
Cubic.
We have cubic feet, so it's going to be feet cubed per, and does it give us a time? Measured in hours. So feet cubed per hour is what our units would be. Okay? Does that kind of make sense to people? Haven't lost anyone? Excellent. Now, if we integrate the rate, it's the amount that it changed. Right? If we have like the rate function and we integrate it, we get how much it changed. This is very related to physics at this point. Okay? So, the integral of r prime of t equals rb minus ra, which is the amount of change, in this case, for our height of the water. So let's write that out. And I'll write it like this so you guys can read it better. This is represents the amount of change in the height of the water from t equals A to t equals B. Okay, how much did it change between those two times, right? Easy enough? Easy enough?
Yes.
Right? Is that right or wrong? Represents the amount of change in the height of the water. Yeah, that's right. So, table below. Oops, sorry. So the table below, I'll wait a minute, I guess, if you're still writing. But basically, if you see a table, you like table questions. Well, I do. I don't know if you do, but I do.
I like
Maho, you like them.
So wait. So the original one is the rate, but then the interval is the change in rate.
The interval is like not the change in rates. The interval would be the amount of change. So like in this case, how much water. So how much water drained out or got added to it, depending on whether we're adding or taking it out. Okay, too much talking, which means you must be done. So we go to here. We're going to approximate the value from 0 to 30. So as soon as you approximate, you should probably be thinking Riemann sums. Okay? Yeah, there you go. Midpoint Riemann sum using correct units. Explain what it means. So it does not tell us how many intervals to use. So if it doesn't tell us, but we need a midpoint, I would probably leave like a space in between, because then we can actually have those midpoints to like find our height. Okay, or find our the height of the rectangle, I guess. Okay, so we can approximate this as the integral from 0 to 30 of VT dt as being approximately, if we look at these, is the width of each one of these rectangles the same?
Yes, 10.
Yes, it's always 10. So we're going to say 10 times, and this is where now we need all our heights. So it's going to be 1.6 plus 3.1 plus 1.6. And I will get that that is 10 times 6.3 or 63 feet.
But I basically what we're doing today is applying it to word problems.
Yeah.
But it's the same theory that
Yeah, it's nothing new really. And what does that represent? Because it asks us to, so we've got our units there, it would be feet, because we integrated the velocity that this is happening, so it would just be the numerical value. So, what about now what this represents? Well, this represents the change in what? Position of what?
The water.
The represents the
Isn't this
height.
isn't water anymore, is it?
No, that's
No, this is the velocity of a particle, guys. I was like, we moved on to a new question. I mean, to be fair, I did not read you the new question, so partially my fault.
Represents the amount of
Change in position of the particle from, I guess technically, yeah, like 0 to 30 minutes. Right, because it's measured in,
minutes.
it says it's measured in minutes there. Let's put it on a single line, there we go. Okay, so let's try the next one. Now we're going to find the integral from 5 to 25.
But also using midpoint.
No? Because we're going to do a of t dt. So if we're doing a of t dt, that would be equal to v of 25 minus v of 5. Do we agree? Essentially, what am I doing? What am I applying?
The theorem of calculus.
The fundamental theorem of calculus, right? Because look at this. This is not v anymore. This is a. So if we want to know what the integral from 5 to 25 of the acceleration is, I know that that would be equal to the function that came before evaluated at those two bounds. Okay? So this is where we got to start reading carefully, right? Ochoa, you're driving me crazy, girl. All right. So then we can plug these in. So what is, I can't quite read it there. 1.6 and 1.6. It's 0 feet per minute. Okay, what does that represent?
That is the constant.
That the velocity is the same.
Kind of. So it represents.
But it starts at the same velocity and ends at the same velocity.
Standing.
Because it might have changed, but they might have
There you go. Exactly. So it doesn't necessarily mean that it like didn't change or anything. It just means that at 5 and 25 it was the same.
The net velocity.
Yeah. So it could have changed. And indeed, we could actually use a theorem to
Rolls.
prove something. Yeah, Rolle's theorem. We could actually prove there's a max or min between them, right?
Yes.
Because if both the endpoints are 0, or both points, sorry, not 0, the same, then we know that there must be a max or min between them. Right, Miguel?
So it's not rolls, because rolls is for zero.
No, but rolls is when it equals 0. So 1.6 minus 1.6 is 0. So that lets us use Rolle's theorem.
Pero si no, debería dividir y ya.
Valentina.
No entendí la-
¿Qué parte?
O sea, aquí tú dices,
Ah, yeah, The usual thing. Yeah.
Porque tú-
pero ¿por qué hizo acá esto primero? Para saber si están en la misma dirección.
Any questions, or should we keep going? Are we talking because we're asking questions, or are we talking about what we're doing on the weekend? You're talking about what? All right, let's keep it going then.
No es actividad discontinua.
Cami,
Sí,
Botero.
You're calling me Otero.
Yeah.
I thought we were friends. It's fácil.
Emma. Sorry, I didn't know that was going to be offensive.
Sí, entonces,
All right, temperature of the water. Ladies. And Esteban. Thank you. All right. The temperature of the water in the tub at time t is modeled by a strictly increasing twice differentiable function w, where w of t is measured in degrees Fahrenheit and t is measured in minutes. So, what does it mean by a strictly increasing?
That is always positive.
Just always getting warmer.
So we don't have to find the zero because we already know.
Exactly. We know that it's always increasing. It's not. We don't have to worry about trying to see like, did it change? You know?
Always strictly increasing.
Because I mean, think about it. This is not going to be total distance, but we could still measure the total change in temperature. And what that's telling us is that it didn't ever go back. It's just always getting warmer. Okay?
So net equals
but if you want to
Exactly. The net change would be equal to the total change in temperature. Okay? All right. Now, using the data in the table, let's estimate the value of W prime of 12. Okay, when we did that, what do we always do?
we
The
take the
average
two
will change.
closest.
The two closest and do the secant line.
So 9 and 15.
Exactly. So we're going to say that W prime of 12 is approximately W15 minus W of, sorry, I did that wrong. I wrote 20, 9. Should be 9. Over 15 minus 9.
You always do the biggest number first.
You don't have to. You just got to keep them the same. Like if I did 9 minus 15, it would be the same answer. Okay. 15 is 67.9. 9 is 61.8. And 15 minus 9 is 6. At that point, I just need to shove that in my calculator. Looks like it's going to be roughly 1.
Mister, what was that? What is the Fahrenheit in 15?
1.16 repeating. What's that?
For 15 is what?
15 was 67.9. Oh my god. All right. What does this represent? So, this is the no, actually,
Medio 1.06.
I mean, it tells us it's strictly increasing, but I guess maybe the conclusion that I would actually think of would be like, this is greater than 0, therefore the temperature is always increasing. So it confirms what the question said. Well, I guess not always, is increasing at 12. At 12 minutes. By roughly 1 degree Fahrenheit per. Yeah, why does that matter? Girl, what are you doing? You just can't get it. You need calculus in your life. Yeah, you do. Come on in.
No, it's Maya's sister.
I know it's my sister.
Maya's.
I know it's Maya's little
smarter
sister.
sister.
The smarter one. She's smarter than Maya. Alrighty, let's do another one. Using the data in the table, let's figure out what is the integral from 0 to 20 of what function?
W prime.
W prime. That is important because that means
Fundamental theorem of calculus.
that since we are going from 0 to 20 of W prime of t dt, it's going to be equal to W of 20 minus W of 0. W of 20, if we go look it up,
71,
71 and 0,
55.
55. So that's what, 16?
Yup.
Awesome. So 16 degrees Fahrenheit.
I wish all that problems were like that.
I know, right?
Eh,
Represents,
I have a dumb question.
probably not, but go ahead.
Why in the other program it was over 15 over now? 15 minus 5 and then this one
Okay.
is not over.
So it's because last time here we were asked to estimate the derivative of the W function. So we have to use a secant line to do that, which means that it's basically our old like rise over run that we did in pre-calc. And here we're asked to integrate the derivative, which basically means they cancel out. The integration and the derivative are just canceling. And so we just need to find W of 20 minus W of 0. So there's no division this time. Make sense?
So when it's like we are
Genius, because one is Esteban's.
Yes. Because then you got to find the slope of the secant line. Yep. All right, this represents the amount of change in temperature, exactly, from 0 to 20 minutes. Excellent work.
Represents the amount of change
Alrighty.
in 20 minutes.
Look, now they're going to give us the derivative. Now they give us the derivative. So, for 20 to 25 minutes, the function that models the water temperature has the first derivative of this. Guys, ladies, there's so much talking. You're driving me insane. Huh? But then ask me. Don't just talk over top of me. Based on this model. See, she's outing you. She's like, no, we're talking about something else.
no, yes, we're talking about this one.
What is the temperature of the water at time t equals 25? Well, remember that if we integrate from 20 to 25 of this function, which we can write out, 0.4 square root t cosine of 0.06 t is going to be equal to W of 25 minus W of 20. Right? And we know some of that.
And we already have the W of 20.
So this one, I know dt. Sorry, you're right. I should have put dt. You're absolutely correct. So here, W20 we know it was 71, right? W25 is what we're looking for. And do we have a way to figure this out now that we have the equation?
Yes, you can take the antiderivative.
I just got to put it in my calculator, right?
What?
Yeah.
You passing?
So let's put it into our calculator. Not that one. I want it in the other calculator.
Make sure you don't say the answer. Let us say it.
Actually, no, we'll just put it in this one. It's easier in this one, I think.
I forgot when you have to put the...
Absolute values? When you're finding the total change, which we're not right now. Ladies and gentlemen, you should be doing this on your calculator, not talking. Miguel and these ladies are clearly talking about other
Don't say
things.
the answer so we can find out.
What, dude, you were talking. I agree, but he was still doing it. All right, what was it? It was 0.4 square root of x
times cosine 0.0066.
cosine of 0.006?
6x,
What
mister.
does it 6 here?
Yeah, why was that weird?
No, just add 0.
It gave me
06.
There we go.
It's just 1 0, 0 0. 0.06. 0.06.
That?
Yeah.
All right. So it should be 2.043. Yeah, 2.043. 2.043. This was done on the calc, this part, this step. And then we're just going to add 71 to that. So So we're going to get that it's 73.043 would be, I guess, hang on, should put Fahrenheit, degrees Fahrenheit, is our temperature after 25 minutes.
Slave.
All right.
But then you don't have to solve from.
That's it.
No, yeah.
All it asked us was for that.
We're flying through these problems today. Because it's como cada periodo dice.
All right, I'll just start writing faster, and then you'll have to be quiet. Ladies, I'm going to kick some of you out for a walk real soon. Pan of biscuits being removed from an oven at which point in time, there we go, t equals 0 minutes. The temperature of the biscuits is 100 degrees Celsius. The rate at which the temperature of the biscuits changes is modeled by the function b prime of t equals blah. Find the value of b prime of 3. Use correct units. Explain the meaning of it. So if the beauty of this is like, I'm just plugging it in, right? Like b prime of 3 just literally means like negative 13.84 e to the negative 0.173 times 3.
Is there a mind?
That's all I gotta do?
Calculator.
Oh, there's a calculator for sure. Yeah, you're not doing that any other way. Work it out for me, guys. Tell me, what is that answer? It's going to be negative
Wait, Mr.
because it's got to be cooling, so it would be negative. Even without looking at the equation, if it's not negative, something's going on weird. Like your biscuits are cooling on the surface of the sun or something. Yeah, go ahead, sorry. I can't chew it anymore anyway.
I'm addicted to
Who did it for me? What'd you get?
negative 6.9.
Nope, that's wrong.
Negative 8.236.
That's the answer. Only because I did it yesterday, so I remembered it was 8 something. Alrighty, so, wow. In context of this problem, I'm just going to start going a mile a minute, guys. Because it is less than 0, that means that the temperature
Is decreasing.
of the biscuits at 3 minutes well, I guess I should say 3 minutes after being removed. That's kind of annoying, but after being
Or 3 minutes cooling.
removed, sure, that works too, is decreasing.
Okay.
And technically by 8.236
Mr.
centimeters.
Is that
degrees
on
Celsius.
paper or on
Which one?
the AP?
I think it's virtual.
Pero
For you guys, I think it's virtual because you are not.
I have to explain it straight. Miss, you have to know this.
All right, but only if you all stop talking. Julia, quieter.
Así. Así.
I could have put it. I said it. Remember how I said I would go back up if we stopped talking? Talking. Technically asking me a question, so forgiven. Not you. You're not forgiven. Okay. All right, let's sketch the graph of this thing and explain it in context of the problem. Ow. So this thing, if you imagine, it's going to be always negative. Is it going to be
exponential.
increasing faster at the beginning or the end? Like,
At the end. No, at the beginning. It's gonna be an exponential graph.
if you've got something that is 100 degrees Celsius, is it going to cool faster at the beginning or at the end?
At the beginning.
At the beginning. So that means that it should look like this. Right? It should look like that.
Why is it cooling faster at the beginning?
Why what? Why
Because
what?
the shock is greater.
Well, because when it's 100 degrees, and then this is just science, right? When you got 100 degrees and the room temperature is like 20 something, right? It's going to try to get to that faster at the beginning. And then once it gets closer, it changes slower.
Why is it all under the x-axis?
Of course.
Why is it all under the x-axis?
Sorry?
Why is it all under the x-axis?
Because it's always negative. Because the temperature is always decreasing and getting closer and closer to like changing 0 degrees.
Okay.
but it doesn't. Yeah.
Like cooling, getting, yeah.
Yeah.
It's getting closer to.
All right. So this is going to take a little bit of work. B prime of t represents the rate at which the temperature of the biscuits is changing after being removed from the oven. The graph of B prime of t is always negative, indicating that the temperature of the biscuits is always decreasing. Caveat here, until it reaches room temperature, which is why it's approaching zero, because eventually it will stop changing. The temperature will get closer and closer to changing 0 degrees, right? Now you're not. You're quiet. How are we feeling about that one? I know it's a lot to write, so I'm going to wait. All right, at time t equals 10, what is the temperature of the biscuits? Show your work. Well,
B prime of t
I know the temperature when.
at 3,
No,
at 0.
at 0. It's 100. So I'm going to integrate from 0 to 10, because I know 0 and I'm looking for 10. Of my function, which is,
Negative 13.
thank you,
0.84 e to the power of negative 0.173 t
173t. Perfect, thank you.
dt
dt,
is equal to b,
I put it already.
b of 10 minus b of 0.
b of 10 minus b of 0.
Mister, but why did we do it differently from when we were doing B prime of 3 and we're here?
Porque es que mira, acá es the temperature at 3 minutes, pero ahí es porque solamente find the value of b prime of 3.
All right, I know that b of 0 is 100. Can I find this?
With calculator.
Put it in your calculator, because honestly, I mean, yeah, put it in your calculator.
Mister, can you tell me?
What?
Why did we
Because
do
it told us that at 0 time it was 100 degrees Celsius. So now let's go ahead and work this out. So I'm going to integrate.
So it's from 0 to 10.
I'm going to integrate exactly from 0 to 10 of 13.84 e to the power of negative
It's negative 65.82.
negative 173. Nope, sorry, 0.173. 65.817. Negative, sorry. Point
Plus,
81. You guys said
it's going to
817?
be 3817, yes.
Plus 100.
It's going to be
34.183 degrees Celsius.
Mister,
I guess I should write that that's B of 10. What is that, dear? No, it's 0.81, 0.817.
Porque aquí me está diciendo find the value of b prime of b prime of 3. Y aquí no me está dando b of 10.
Does that feel good?
Pero aquí no está preguntando at.
Should we look at the next one?
What is the temperature of the biscuit?
eso acá porque significa que the temperature of
What? Waiting.
biscuits at 3 minutes.
Prime, y aquí
So our last one. Cylindrical can of radius 10 millimeters is used to measure rainfall in Stormville. During the first 5 days of a 60-day period, 3 millimeters of rainfall has been collected. The height of the water in the can is modeled by the function S, where S of t is measured in millimeters and t is measured in days. The rate at which the height of the water is rising is given by this function,
Positive.
S prime of t. Find the value of 10 to 15 of S prime of t. So, we're going from 10 to 15 of S prime of t. Oh.
Do we write that function there?
We write the function.
You could write out this function, but realistically, what are we doing?
The one of equals the.
Yeah, we're gonna integrate it. And so,
P of 15.
I mean, we could do it by hand, I guess, but Realistically, it's not really going to be by hand. No, actually, you guys don't know how to do that by hand yet. Never mind. I haven't taught you the trick how to do that. Forget I said anything.
What?
Forget I said anything. I said nothing. All right, what is this? From 10
Okay.
to 15.
But they could be different. It's 2 sine of 0.3 t.
What was it? 2 sine?
After we finish this, what are we going to do?
Hold on. Guys, you're way too loud. Like they're trying to tell me the question and I can't even hear it. I'm going to just start kicking you out. That doesn't mean keep talking. Back table and front table of ladies. End table of ladies here. Go ahead, tell me the question, guys.
¿Cuál es la próxima lesson?
María, qué loco.
All right, which means I'll need another parenthesis here to show that I'm integrating everything.
Okay.
11.159.
That's crazy.
I keep saying, ask me.
Because you answer the question at the end of the program.
Oh, I let you. You can ask me anytime.
You say, shut up, ask the question at the end.
No, that's not true. That's not true.
Good, that's-
All right, what does this represent? If I'm integrating the rate,
The volume from the change in volume from 10 to 15.
right? So the word that we should get really used to is it's the accumulated change in height, because they're going to use that on the AP exam. They're going to use that accumulated change terminology. I gave it to you when we first learned the fundamental theorem of calculus. Okay, so it's the accumulated change in height of the water from when to when. Good. From 10 to 15, and it's days, measured in days. Does that make sense enough?
Why accumulated?
It's accumulated just means like how much of it was added all up. So we're saying accumulated, there was this much change in the height over 5 days. It's just a terminology that they like to use. What you guys said earlier was like it's the total change in the height. That's fine too. But it technically, we can also say it this way.
Okay.
All right, end of the 60-day period. What is the volume of water that's accumulated? So this time, I need to go from where to where? 5 to 60, because I know 5. They gave it to us. That's our initial condition, right? Right here, they told us during the first 5 days, there's 3 millimeters. So that means that when t is 5, we have 3. So that's my initial condition. So then I'm going to take that of s prime of t dt. Going to make that equal to s of 60 minus s of 5. And I know that s of 5 is 3. And then I need to use my calculator to figure out what is that. What is the integral from 5 to 60? Well, we haven't found it. But we went from 10 to 15. So all we're going to do is change the bounds so you guys can copy it in your calculator. What was it, 5 to 60?
Yes.
Okay, 5 to 60. So we should get this.
Sir, are we working in radians or degrees?
Always radians. Always radians.
For the exam, always read.
Always radians. So I get 163.564. Guys, when you're doing this, just copy it in your calculator too. You can just highlight it, hit enter, it'll copy the whole thing again. Okay, and then you just change the bounds. So 163. Oops.
That means it's possible.
163. I forget what it was. Point what? What?
565.
565. Thanks. And then we're going to add 3. And so S of 60. 163.565. Did somebody say that was wrong?
No, 1666.
56. No, 56 is 5. Because it's
No,
4,
but,
8.
but you didn't add the 3. You put the same value again.
Ah, thank you. Yes.
1.66.
You're right. I forgot to add the 3. There we go. And what would that be?
The accumulated change in volume.
So then
from
what are units?
5.
You're right.
Millimeters cubed.
Millimeters cubed. Yes. And you're correct. Yeah.
Why cubed?
Because it's volume. One last question. We're going to talk about a concert. Don't make fun of the concert question. The concert question does not make sense in Colombia. I am aware. Every year they tell me.
Well,
I
don't
don't
make
care.
sense.
Well, just they always tell me that it's ridiculous. But anyway. Okay. It's because you guys go to concerts like a day before they start. Yeah. What's up?
Wouldn't the answer of the problem just be like the 100 and like whatever the integration gave us? No, yes, forget it. Yeah.
Okay. All right. Rate at which people enter an auditorium for a concert is modeled by the function R given here. Okay, so that is already going to be a rate. Even though it's not said like R prime, it is a rate, right? Okay. R of T is measured in people per hour. VIP tickets were sold to 100 people who are already in the auditorium when the doors open at T equals 0. So that's our initial condition, right?
So 0.
When T equals 0, we have 100. Okay. For general, yeah. So when doors open, the doors close and the concert begins at T equals 2.
So
This
we're
is the
going
reason
from
I say
0
I
to
know it
2.
doesn't make sense here because they're closing the doors after 2 hours, and I understand you guys go to concerts, like I said, 12 hours early.
Okay, but then we're integrating from 0 to 2.
Yeah. Yep. All right. If all of them stayed stayed for the start of the concert, how many people are in the auditorium? All right. So we're going to integrate from 0 to 2, as Mariana said. We have 1380t squared minus 675t cubed. Brackets around all that so that I can write dt.
Can I just do RT?
Yeah. And this is going to be equal to r of 2 minus r of 0. Where in this particular case, this r represents the function that
We
came
have the
before.
value of R0.
100.
See 100.
So r of 2, and then the number of people that were there already is the VIP ticket holders, so 100 of them. And then we need to put this into our calculator. So let's do that. So I'm going to integrate from 0 to 2 of 1,380x squared, or t squared, minus 675x cubed. And so I get 980. So 980. Then I add my 100.
1,000.
And I get 1,080 people when the concert starts. So there should be 1,080 people there when the concert starts, 2 hours after the doors open.
Perfect.
I mean, just because you're from Medellin. But yes, that is a really small concert, I agree. Even for like a small town, that's a pretty small concert. I agree with you. And we're good.
And if that wasn't a race, no, it had